Hello everyone, welcome to grade 11 General Mathematics class. We are now in module 3 and our topic is all about operations on functions. So here are the prerequisite skills. So you should know the rules for adding, subtracting, multiplying, and dividing fractions and algebraic expressions, real numbers, especially fractions and integers. Another one is you should have the skills in evaluating a function. Now, below is the presentation of two functions represented by a piggy bank. We have here NIA, f of x equal to 5x plus 10, and NEO, represented by a function g of x is equal to 3x plus 5. If we're going to combine both of them, we will get h of x is equal to 8x plus 50. Okay, that is a representation of two functions combined together. Okay, let's start with the definition. Let f and g be functions. Their sum denoted by f plus g is the function denoted by f plus g of x is equal to fx plus g of x. If you see the symbol, of course, we know that that is an addition. So we combine them, we get f of x plus g of x. Next, we have the difference, denoted by f minus g. You know this one, subtraction, is the function denoted by f minus g at x is equal to f of x minus g of x. So, if you see this symbol, subtraction, you know that is a subtraction of functions. Another one, their product, denoted by f. This is the symbol of multiplication. G is the function denoted by f times g at x is equal to f of x times g of x. So this is the symbol for multiplication. Next, we have their quotient denoted by f over g. Is the function denoted by f over g at x is equal to f of x over g of x, excluding the values of x where g of x is equal to 0. So, if you say this symbol, that denotes division. So, but of course, g of x must not be equal to 0. Okay, so we have another one. The composite function denoted by, I think this is new to you. This is open circle. That means it is all about composite function. F composed of g at x is equal to f at g of x. The process of combining a composite function is called function composition. So, okay, do you have any question on this? Now, let's have an example. Given the function, so we have here three functions. F of x is equal to x plus 5, and another function g of x is equal to 2x minus 1. And another function we have here, h of x is equal to 2x squared plus 9x minus 5. Okay, we're going to determine the following functions. So we're going to have a combination here. So it says here that f plus g at x. That means we're going to use the operation addition. Okay? So here is the solution. So f plus g at x is equal to f of x plus g of x. Okay? Definition of addition function. Now, take a look on the functions above. So, we have here f of x, right? Our f of x is equal to x plus 5. And our g of x is equal to 2x minus 1. Now, let's substitute them. So, we have f of x here is equal to 5x plus 5. Okay, we're going to use this one. Plus 2x minus 1. So, we have here g, 2x minus 1. This one here. So, we just replace the value of x, f of x, and g of x by the given values. Next, we're going to combine like terms. When we say like terms, they are the same term. So, in here, as you can see here, we have x. We add it with 2x. They are like terms. Why? Because they have the same variable, which is x. Okay, so we have x plus 2x. We have here 3x. And we have here 5 and 1. They are constant terms, so we're going to combine them. So we have 5 minus 1 here. We have here 4. Okay? So do you have any question on that? Next. So the same functions, but this time we're going to get their difference. So you can see here, this is subtraction. So f minus g at x is equal to f of x minus g of x by the definition of subtraction of function. So we are going to use the function f of x, subtract g of x. So take a look again at the functions above. So we have here x plus 5, and for g of x, we have 2x minus 1. Okay, so we have here, we substitute or replace f of x with x plus 5 and g of x by the given values. So this one, x plus 5, that represents f of x. And then we have here subtraction sign. And then our g of x is equal to 2x minus 1. Okay? So we got it from here and from there. Okay, next. So we're going to remove this open and close parenthesis symbol here in order for us to simplify. So if we're going to remove this open and close parenthesis, so we have here x plus 5, this one, and this one is plus, and then we have here 5. Okay, so we have here, we're going to remove this open and close parenthesis. We will adapt the symbol. So we have here minus 2x, and then the other one, why is it that this is positive? Because negative times negative, we have positive. So we have here positive 1. So distribute the negative sign. Okay? Next, we're going to combine like terms. Same as in number 1. We're going to combine x and minus 2x. So we have here x minus 2x. We have negative x. And then combine 5 and 1. 5 plus 1, we have 6. So therefore, our answer is negative x plus 6. So we cannot combine negative x plus 6 because they are not like terms. They are different terms. Okay? This one is variable and this is a constant term. Another one. Now we go to multiplication. So if you see this symbol here, that denotes multiplication. So we are going to multiply f of x times g of x by the definition of multiplication of functions. So still the same functions that we're going to use. Now we're going to replace f of x and g of x by the given function. So we have here x plus 5 times 2x minus 1. Okay. Next, we're going to multiply the binomial. So how did we do that? Multiply first term and second term. So x times 2x. We got 2x squared. And next we have x times negative 1. Okay, I will write here. That becomes negative x. Okay. And next we have 5 times 2x. Our answer is plus 10x. Okay, I'm sorry for my writing. So we have 10x. And then, so this now becomes our middle term. But we're going to finish first the outside term. So we have 5 times negative 1. We got this one, negative 5. So we will simplify this to get the middle term. So negative x plus 10x, we got 9x. Okay, that's why we have there 9x as our middle term. Okay, we just multiply the binomials. So I hope you can remember that. You studied that when you were in junior high school. Okay? Next, the same function. This time we're going to divide the two functions. We will divide h and g at x is equal to h at x divided by or over g of x by the definition of division of functions. So this time we're going to use h, this one h, and g. Okay, so we will replace them. Replace h of x and g of x by the given values. So we have now here 2x squared plus 9x minus 5. We just copied the function h. And then over or divided by g of x. Our g of x is equal to 2x minus 1. Okay, we're going to factor the numerator. So if you can still remember factoring during your junior high school, the factor of this is, the factor of 2x plus 9x is equal to 5. Okay? So how do we factor again? Square. What do you call this? Trinomial. Okay, we will review. So we have here 2x squared plus 9x. So review your factoring trinomial. And so we have here 5. So let us factor that. So first, yan, we will make two open and close parentheses, and then we factor 2x squared. We will place that on the first term here. So factors of 2x squared are 2x, and we have x. To check that, 2x times x, we have 2x squared. and then we factor negative 5. So if we're going to factor negative 5, we're going to use, what are the factors of negative 5? We have negative 5. Factors of negative 5 are negative 5 and 1. Okay, it's up to you where to put negative 5, but we are going to check on the middle term. Okay, so since our middle term is 9x, I think I'm going to put 1 here, and then the other factor is here. Now, let us check the middle term if we got the right combination. So, we have here negative 1 times x, negative x. And we have 2x times 5, we have 10x. Okay, so if we're going to add the two, we have negative x plus 10x is equal to 9x. And so we got the correct combination. Okay, so we have here 2x minus 1, this one here, 2x minus 1, and x plus 5. We have here x plus 5. And divide it with g, function g, which is 2x minus 1. Okay? And now, we're going to factor out common factors. So, as you can see here, 2x minus 1 and 2x minus 1 on the denominator. We just eliminate that because 2x minus 1 divided by 2x minus 1 is equal to 1. So, what is left now is x plus 5. Okay? So, my tip for you, or you should know how to factor functions, okay, or algebraic expression. We're going to recall on that. Next, okay, so we go to a combination of evaluation. Okay, so we have here f plus g. Okay, all right. As you can see here, this is addition. So now this time we're going to use the value of x, which is 3, and at the same time, the same with function g, we're going to use 3. So in this function, in this f, we're going to use 3 in replacement of x. Okay, the same thing with g. That is the meaning of that. So we have here f at 3, meaning we're going to replace x with 3, and g of 3, we will replace 3 in x. Okay, so solve for f at 3 and g of 3 separately. Okay, so we have here f of x is equal to 5x plus 3. Since it says in the given that we're going to use 3 as the value of x, so therefore we have 3. Our x here is 3, and then plus 5. So our f at 3 now is equal to 8. Okay, we are done with f at 3. Now we go to g of x. We're going to use 3 here as the value of x. So we have g of x is equal to, so we have here 2x now becomes 2 times 3 because the value of x is 3. And so we have 2 times 3 is equal to 6 minus 1. Okay, this one is 6 minus 1. We have 5. Okay, so therefore, the value of f at 3 is 8 plus the value of g at 3 is 5. Therefore, the answer is 13. Okay, do you have any question on that? Okay, next, we go to the next. For item f to h, we will use the values of f at 3 is equal to 8 and g of x is equal to 5. Okay, the one that we solve on the first one, we're going to use them as the value of f at 3 and g at 3. Okay, so we have here subtraction. Okay, so as you can see the symbol subtraction. So f at 3 minus g of 3, definition of subtraction of function. Since we all know that f at 3 is equal to 8 and g at 3 is equal to 5, we just replace them. And so our answer is 3. So 8 minus 5, we have 3 because this is subtraction. Okay? As simple as that. Next, we go to the next. So this is the symbol for multiplication. So we have f at 3 times g at 3 by definition of functions. Okay, so we have here the value of f at 3 is 8 and g at 3 is 5. So we replace f at 3 and g of 3 by the given values. So we have here 8 times 5. 8 times 5 equals 40. Okay? Any question? Next, we have here letter H. Okay, so this time we're going to divide. We're going to use division. So we have H and G. So we have H and G. So we are not using F anymore. We're going to use H, function H. Okay, solve for H at 3 and G at 3 separately. Okay, so let's begin with H at 3. Our function H is 2x. This one, 2x plus 9x minus 5. Ayan. This is it. And then, we replace the x with the value of 3. Okay, the value of x now is equal to 3 according to the given. So we have here 2. Our x here is 3. And we have the exponent here 2. Okay, and then we have here addition. Addition also. We have here 9. We copied 9. And then replace x with 3. And then we have here minus 5. Okay, any question on that? And so we have here 2, 3 squared or 3 times 3 equals 9. And we have here plus 9 times 3, that is 27, minus 5. And so next we have here 2 times 8, we got 18. And then we have here addition, 27 minus 5. Okay, what do you think is the answer? Okay, so how did we get 40? So we have here 18 plus 27 is equal to, what is 18 plus 27? That is equal to 45 minus 5. That's why we got 40 here. Okay? Next, we go to G at x. Okay, we're going to replace x with 3. So we have g at 3 is equal to 2 times x is 3. This now is 2 times 3. That is 6 minus 1. That is equal to 5. Now we got the value of g at 3, which is 5, and h at 3, which is 40. Now we're going to proceed with this. Now we go to this one. Since x at 3 is 40 and g of 3 is equal to 5, we just divide them. So we have 40 divided by 5, we got 8. So do you have any question on that? Any question? Okay, thank you for listening. Next lesson is all about composition of function. Okay, that is the 5th operation of function, the composition of function. Thank you for listening. I hope you enjoyed watching.